Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you so much for all participants in this room who are still attend my presentation, especially for the moderator and host. My name is Erna Piantari. I'm a faculty member in Computer Science Education in Universitas Pendidikan Indonesia. And in this opportunity, I would like to present one of my research, which is sessional space-time based model for infectious disease prediction. And this research was conducted in collaboration involving three authors, myself, Erna Piantari, Ikdam Musyayat Rabani, and Dr. Rani Megasari. First of all, I would like to discuss about my agenda in this presentation. Firstly, I will present about the background of the research, then what is the problem of the research and the proposed solution, and what is the method and its implementation. And the last, I will present about the result and the conclusion of the research. Talking about artificial intelligence, the development of artificial intelligence has highly contributed in improving the quality of human life, especially in healthcare. Artificial intelligence or AI has an essential role. There are eight rules that is for early detection ailments, and this is very important uh, to prevent the high risk of this disease. And the second is improving the decision making, and the third, helping in treatment. And nowadays it's happened in some hospital in Indonesia also. And then artificial intelligence also can expand access to medical service, can do for associate care, giving a superior experience, and checking health through wearable, which is this is very popular nowadays through smartphone, and end of life care. In this way, artificial intelligence help to make experience better for critical ill or old age patient. However, in our research, we are focused in the first and the second rule, that is early detection element and improved decision making for infection disease problem. Infection disease problem can be defined as the disease caused by bacteria, virus, and other microorganisms that can pass from an infected person to another person. The pattern of infection disease incident become one of the most interesting study that can be used to predict the incidence of disease spread for improving decision making and early detection of ailment. In addition, one of the infection disease that quietly deadly, especially in toddler, is ARI or acute respiratory infection. In Indonesia, we know it as ISPA or infeksi saluran pernapasan akut. ARR can be caused by virus, and in Bandung, ARR become the government concern due to the number of ARR patients in Bandung is very high. The proliferation of this virus will be grow under certain conditions, such as exposure to cold temperatures originating from the environment. Change the day-night cycle can affect the human system and increase susceptibility to infection. And also the environment with low humidity also can increase ARR infection. Based on that background, we conduct this research to build a model for ARR prediction. There are some problems in this research to build a seasonal model for ARR. Seasonal autoregressive integrated moving average or SARIMA is a time series model that is considered to have a good accuracy for seasonal data. However, the virus that causes ARR also has a complex spatial temporal pattern, such as a biological, socio-demographic, and environmental factors. This then has the greatest influence on the spatial pattern. Therefore, we need to consider the model. We need to, in building the model, we need to consider both spatial and temporal pattern. And STARIMA is the extended of SARIMA modeling. that has time and space lag for modeling process. Next, I would like to present what is the research method that we build in this research. Firstly, we do pre-processing data due to our data has some missing value, so it's need missing value handling and cleans the data. After that, we start to build Starima modeling by transform the data and then calculate spatial weight, which is this is the most important step that we propose as a solution in this research. And then we do test stationary, do identification model, estimate parameter, and then we do evaluation model. From this process, then we can produce the best Tarima model. Next, I would like to present briefly the main step on our method, that is calculate spatial weight. The value of spatial weight affect the identification of Starima model. This is very important. The value of spatial weight hereinafter we refer as spatial order. In this paper, we propose to use district neighborhood structure to define the spatial order as shown in this figure. For each district, other districts that are directly adjacent from west, north, east, and south are included in order 1. Then other district adjacent to order 1 district were included in order 2. Then other district adjacent to the other 2 district were included in order 3. Therefore, the weight metric for each spatial order will present in these metric forms. The next step is do stationary test using STACF value. This is the formula of STACF, and in this page I show the spatial correlation in figure 1, and the figure 2 is the STSCF hologram. Figure 1 is the correlation between spatial order lake, and the figure 2 shows first this is shows the initial significant spike to the temporal leg, which is quite far, but this is indicate the seasonal, it's the data has seasonal pattern, but the data is not stationary. That's why we need differencing transformation to do before STSCF observe. After the differencing, then we do STSCF collect the STSCF calculate, and this is the STSCF after the differencing. And after the differencing, this show there the data is stationary. After the stationary test, we did model identification, estimate the parameter, and the best model were obtained. And this is our best model, and this is the linear regression equation of our best model. As a result, to evaluate the model, we compare performance of Starima model with Sarima, or sessional autoregressive integrating moving average model in the same with the same data. In the left is the plotting for Sarima model, which does not consider space lag, and in the right is the plotting of Starima model, which consider the space lag. By observing this visualization, we can conclude that Starima model tend to be better than Sarima model. Here, can be seen from the gap of the prediction line, and the data real line is smaller in Starima model than Sarima model. In detail, we evaluate model using RMSI and MAI value. This is RMSI and MAI value for training performance. Sarima, all the training performance of the Sarima model is better than Sarima model in all districts, both in RMSI, RMSE, and MAE. And for the testing data, testing performance of Starima model is better in 5 districts than Sarima model in RMSE, and 6 districts better for MAE in 6 districts. For the testing performance, that we can conclude that Starima is still better than Sarima. So it means that Starima is quite good and quite promising for predict the data. From the research, we have some conclusion. First, spatial weight metric play an important role in the prediction result of Starima model. The order and initial parameter value of the Starima model were determined from STACF and STPACF. Both computation include the value of spatial weight metric. So, to calculate the correct spatial weight metric in this research will be greatly affect the prediction result of the model. This is the best Starima model that we produce with average MIE presentations for training is 90.34 and presentation of MA, MAE test for testing is 28.10 as a model, the best model for ARI prediction in Bandung. This is our reference, and this is the end of my presentation. Thank you very much for your attention.